Okay, well today we're going to be talking about scientific notation, which is in section 7.2. Our objectives for today are to write numbers in scientific and standard notations, and to compare and order numbers that are using scientific notation. Okay, we're still in A1.4.1. Okay, so that's kind of a big standard for us in this first half of this section. Okay, first thing is the key concept of what a scientific notation is. Scientific notation is written as a product of two factors in the form of a times 10 to the nth power, where n is the integer from a is between 1 and 10. Okay, so the big key to this section is understanding what the purpose of scientific notation is. Now, you've probably seen this in science class at some point, but this is real big for like writing in journals. There's some really large numbers and there's some really small numbers that we don't want to write over and over and over, because there are just so many zeros, so many decimals, places that we have to put in. So we use what we call scientific notation. So for example, right here we have a scientific notation. So the key is that this a, the number, must be between 1 and 10. So this is 8.3. That is a number between 1 and 10. This one is 7.1, which is a number between 1 and 10. And I should note here that it could equal 1. I mean, you could have 1 times 10 to some power, which would be the same. And that would work. So it can include 1, but it cannot be 10. So essentially, you can't have a 2-digit decimal here. So like if this would have been 18.3, then that would be a no. That would not be in scientific notation because it's not in that format. The second restraint is that it must be 10 to some n power, and it must be an integer. So -5 is an integer, so it works. Now if I would say times 10 to 100 to the 5th, it wouldn't work because that's not 10. Okay, so it must be 10. Alright, so let's look at some examples here as we go through. We have the first problem, 0.23 times 10 to the 4th. Is that scientific notation? We would say no. And explain why not. Because it's 0.23. Okay, it's not 1.23 or 2.3, so that does not work. What about B, 2.3 times 10 to the 7th? We would say yes, because that is 2.3, which is a number between 1 and 10, and it is 10 to the 7th power, which does work. Okay, and the last one, 9.3 times 100 to the 9th. Again, we would say no, because of the 100. Okay, it must be 10 to the 9th, or whatever that version would be once we start rewriting. Okay, so example number 2 here, go ahead and tell whether this is and explain yes or no. Again, we'll look at the answers in the back. Problem number 2, writing a number in scientific notation. So approximate the distance between the Sun and Saturn. If I had this large number, so again, we don't want to write this. If I have to refer to this 2-3 times in a journal or in a book or something, I'm going to get really tired of writing that. So what we're going to do is we're going to locate the position to make this a number between 1 and 10. So that would be 1.43. Now the key here is you have to write all the zeros if there was a number after one of them. So if I had a 1 down here at the very end, I would have to include all these zeros. I would have to put 0, 0, 0, 0, and then the 1. Since there is none, I do not. Okay, so you have to write all non-zero numbers, and then you would write any zeros that were in between non-zero numbers. Okay, so I have 1.43. I'm going to use x. Again, we're using x for the multiplication, which I know I've told you we don't really like to do, but in scientific notation we do. Always times 10, so really this stuff should always be in every problem. But now we ask the question, how many times do we have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get back to that original number. Okay, there's a decimal, the original decimal's down here. So that's where I get my 9. Okay, so same thing on part B here. In order to get this to be the number we want, it has to be 1.0. You can leave it 1, you don't have to write the 0.0, times 10. So we write that. And then we ask how many times we have to get there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. But this time we're going left. So to go left would be a negative. So this would be a negative 10 times. And going back to the first problem, we'd have to put kilometers on that. And then here we would have to put meters on that. So that's how you would find it. So if you move to the right, so where you put your number, to go back to the original, you have to move right, it's a positive exponent. To move back to the original number and then go left, then it would be a negative exponent. Okay, so got it, number 2. I want you to go ahead and do this one. Again, we'll check those at the end of this lesson. We'll go ahead and stop there for this video. Go ahead and get back on for part B and see how we're going to write standard notation stuff.